What's up? Part two is gonna be 10 parts, obviously 10 chapters. We're on cell signaling, so it's just great. Let's get straight into it. Okay, I'm gonna go from back to front, so I'm gonna like work my way to the middle. I don't want to just do like the beginning and then just get too lazy and not do the end, and or just do the end and not be too lazy to do the beginning. I might as well just like slowly come in. Pause. Okay, let's go. 45 minutes. We should be doing 5 minutes. Okay. Okay. Cell signaling. Signal ligands. Okay. What is it? Like a receptor is gonna. Okay, I actually really understand this chapter. I think I can finish this in like 10 minutes, 15 minutes. All right, so a ligand is gonna bind to an outside receptor. It's actually inactivated. Then he's gonna get activated, and then he's gonna bind to some other thing, and then to some other thing, and some other thing. We're gonna get like a effector response. Okay, what effector? It's effective enzyme, transcription factor. It can be an ion channel. It could be a lot of things. Transport protein. Effector can be transport protein as well. I always forget this. Okay. Exhibit ligand binding and effector specificity. I knew that. Effector mediates specific response. Yep, I knew that. So the receptor protein is very specific to the ligand, and he actually controls a lot of he's very specific to the actual thing, like the actual reaction. But the effector is the actual thing that mediates the cell response and mediates the actual thing. I never remember this thing. Receptor. I never remember this word. Receptor signal complex. Examples. Yeah, I don't remember this. Retinoids. Oh, examples of hydrophobic signals. That's a good question. Obviously, steroids. Retinoids. I don't know what that is. Thyroxoids. Thyroxin. Sorry. Sign off. Oh, it's playing on my phone. Damn, that's loud. Am I gonna get copyrighted for this? Yo, he creates like a copyrighted. It actually did get copyrighted. That's crazy. Wow. Maybe I shouldn't play this. Copyrighted. Does lo-fi copyright? Bro, at this point, bro, it's not even worth it, bro. Just study. Sorry. To get rid of it. I'm not dealing with that stuff, bro, later. Hydrophilic. Okay, I know it's going to be protein, peptide. Is there anything hormone? Everything's a hormone, actually. What's the examples that they have? Small molecules, peptides, hormones. Hydrophilic signals, peptides, hormones, small molecules. All right. Now examples of that. Examples of peptides. I don't know actually. I think it's right here. I'm not gonna remember that on the exam unless I write it down here. What's that? Hormones, glucagon, epinephrine. Nope, it's not even right. We've been outside, not going in. Pull up in the limbo. Just side speaker, send recipes. Peptides, yeast. Okay, so I'm gonna just remember right now. A peptide, a yeast manufacturer, and growth factor, and then a hormone. Is it gonna be insulin and glucagon, and then small molecule is gonna be acetylcholine, and adrenaline. Oh, what peptide? Wow, I don't know. The peptide is the glucagon. The hell's going on? It's like it always happens when I'm studying, bro. It's some random stuff. It's such a stupid class, bro. No, the class is actually really nice. I think just, I don't know. I think this is just so simple, and then like I'm writing down stuff I already know. That's what I mean. I don't even know what epinephrine is. I know it's like a. I can't explain it. I can't explain what it is, unfortunately. I think it's from an amino acid. Like I know what this stuff is, bro. That's why I'm not trying to write down like everything, cause there's no point. It's a waste of time. I know that's growth factors. Yep. But what is it? I hate that. It's like those complicated sentences, bro. Cause not need to say it like this. It's like it is possible for the same ligand to bind its own receptors on different cells. Like, come on. What is that? How would you like translate the sentence? One ligand. This is the most complicated sentence ever. One ligand can have the same receptor on multiple cells. That was saying. which leads to different responses. Is that what it's saying? And then different ligands can bind to their own receptors on the same cell. I think it's saying that ligands can bind to multiple cells that have their like receptor, and that could lead to different shit. And that's also saying that different ligands can bind to their own receptors, and all these different ligands end up having the same response. I think that's what it's saying. Acetylcholine, choline versus glucagon receptors. How much time do I got? 33 minutes. Hopefully that can be done in 20 minutes. I know that I know that it's gonna be in muscle cells. What the hell? A glucagon receptor is obviously gonna bind to glucagon, which is gonna cause glycogen to be made into glucose to increase blood sugar. The three kinds of hormones I know is small lipophilic hormones and freaking water soluble hormones to have their own receptors. And then you have like the normal big lipophilic hormones. Yeah. Like I know what this stuff is, bro. It's just like the names and examples that I just need to hone in on. Can't write for shit. This is the worst example ever, bro. So much shit that you didn't need to write, and it's just so formatted wrong. It was so complicated to memorize this. Dude, I read this so many times, but inhalers for constructive, obstructive. It's not constructive. It's complement. Obstructive pulmonary disease. You have a freaking inhaler, and this inhaler is gonna have fluticasone, and it's gonna have a it's gonna It's gonna have a corticosteroid and a bronchodilator. The corticosteroid is gonna have fluticasone, which is gonna cause like long-term change, and the bronchodilator is like gonna be fast. It's gonna have something called salmeterol, and it's gonna be like it's gonna like open the airways, and then you're gonna have something called albuterol. It's gonna be like fast. See, that's the thing, bro. That's the thing. I know it, but like it's like little stuff like this, like fluticasone. We been outside, not going in. I know it's not a steroid, bro. That's what I said in the beginning, right? We been outside, not going in. Pull up in the Lambo and the bin. I got the chopper and off the lead. It's always better off the lead. I'm outside, not going in. Oh yeah. We been going outside. I'm on outside. Pull up in the street, probably never drive by. It's always better off the lean. Thyroxine. And the synthetic version is something called levothyroxine. And people that don't have thyroxine, they have something called hypothyroidism. And so they're going to become really fat because their metabolism is slow. So they use levothyroxine to compensate. Is that right? Right? Yeah, that's exactly what I said. Retinoic acid. What else would it come? What else would it do? Retinoic acid, cell proliferation, differentiate. No, there's actually a different thing. Death. Water soluble hormones. Okay. It's always better off the lean. Not going in. We've been hanging outside. Not fake. Two types. I don't know what a freaking peptide is, bro. Getting mad, bro. Okay, I remember now. The peptide hormones was insulin and growth factors. Yeast or growth factors, right? Oh, now it's not. I swear to God, now it isn't, right? Right, it was right here. Glucagon is a pep. Okay, I need to relax. Cannot travel. I mean, obviously, it's obviously water soluble. I don't need to say that, bro. It's unnecessary. Let me like zoom in for y'all. I know y'all want to see this. Small charge molecule. What example? The acetylcholine, epinephrine. I think adrenaline. Yo, as kids we used to do this a lot, and then smoke will come out your mouth. I don't know how. Don't ask me. That's exactly what happened. It was actually mad crazy. Kid would do anything to smoke back in the day, bro. They'd smoke Smarties. They'll do that. Tyrosine. First example, we have our best friend, prostaglandin. Continuous, I don't know what that means. Yo, I'm actually getting tired now, bro. I don't want to do this anymore. And I have a website to develop tonight, and then I have to I got an exam tomorrow, bro. I'm not know if this is worth it, bro. No, actually, really. Arachidonic acid. What's wrong with me? Now, how am I gonna write this down? How am I gonna remember this, bro? I don't want to just like write shit down, bro. All right. Hadvil, Motrin, aspirin, Aleve, Celebrex, off market. Just put this into red. This is writing shit down, bro. How am I gonna remember it? Advil. Okay, that's obvious. It's gonna be Advil, Motrin, ibuprofen is the main name. Aspirin, Aleve, and Naproxen. Okay, these are like the main names on it. I think this is like the real name. I was so lazy this weekend, bro. I don't know what constitutional means, bro. Inducers are cytokines, growth factors, TNF alpha. There's 3 types of signaling proteins. It's GTPase, protein kinase A, adapter proteins. Okay, this is actually pretty easy. Okay, GTPase, I'm gonna just say everything I know. GTPase proteins can be bound to GTP, and when they're bound to GDP, they're inactive. When they're bound to GTP, they're active. They can hydrolyze their own. No, they can't hydrolyze. No, they can hydrolyze their own. I can bring it off. Protein kinases are activated when they bind. They can phosphorylate. They phosphorylate. Um, yeah, I think when they get active, they phosphorylate other things. And adaptive proteins, they have like a proline rich region. They have a thyroid. They have a damn. They have another region, and that has like SH2 and DW and all that crap. We'll get to it. We been outside, not going in. I don't even know what this means. I think they're all activated. Shit. Serine, histidine, tyrosine, threonine. Get off my face. Protein phosphatases. We're getting outside, not going in. Hosting, rapping, well, you sleeping on me. Cause last week at Rest in Peace, the homie. That was tough. Secondary messengers. The three types are camp, jamp. What? Is it really jamp? It's not camp, it's C-gimp. 1,2-diacylglycerol. It's like inositol. I don't even know what this means, but it's something that he might like ask, right? There's 4 types of receptors. G protein is ion channels. There's going to be receptor tyrosine, and there's going to be like enzyme linked. Tyrosine linked receptors. It's a completely different thing. I know how this works, bro. Epinephrine, serotonin, and glucagon. It's just examples I don't remember. This is actually something important. It's like sort of. I don't understand this one. Atrial natriuretic factor, tyrosine kinase activity, nerve growth factor. So yeah, the I don't even think I need to know this. I think it's like it's an effective enzyme, SM dependent, active, adapter, map. It's easy, bro. I'm just proud of just because I need to like know the pathway itself. That's fucking easy as hell. There's no way we didn't know about this until 2020. Get the hell out of here. Alright, so freaking, let's say beta adogenic. It's receptor's gonna increase that. It's gonna go da 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 da. Smooth muscle. All right, we're done with this chapter. This took a while. I'm just screenshot this shit if I want to read it later, and it's like read through this. Yeah, this is actually really simple. All right, it should be good. 5 pages. This is actually a lot, but it's a lot of crap in here. I could just like remember. I don't have to read this chapter again. Thank God. All right.